Prometheus and InfluxDB OSs are single node by default. One process, one disk, one query engine. Great for monitoring a handful of servers, but it falls apart the moment you are running a fleet. Past a certain scale, one machine can't ingest fast enough, can't hold enough on disk, and can't answer a query before it times out. So the architecture has to change the shape entirely. The fix? Remote write. Lightweight agents like Prometheus instances. Open telemetry collectors sit close to the source. Tape locally, buffer briefly, and ship data over the network to a horizontally scalable backend like Thanos, Cortex, M3DB. No single box ever ingests the whole company's metrics. You just add more backend node as the volume grows. Backend has to spread data across the nodes as well. Usually, it's sharded by series, writes, and storage. Scale horizontally instead of bottlenecking on the disk. Now reads get more interesting. Query, like CPU usage in last 24 hours, doesn't hit one node. It fans out across every shard that may be holding the relevant data. The querier in Thanos, the query frontend in Cortex, collects partial results and merges them into one answer. That's federation. And it's also where most of the latency in distributed TSDBs lies. Now replication sits under all of this. Each shard's data usually exists on more than one node. So losing a single machine doesn't mean losing data. Just a brief dip in read availability while the cluster catches up. Talk about the trade-off. Distributed metric system lean hard on eventual consistency. If your CPU dashboard is 2 seconds behind the reality, no one notices maybe. But swap that server metrics to financial tick data, and that same 2-second gap becomes a real money problem. That's why fintech and trading time series need a really strong consistency guarantee for it in write latency. Metric system would never tolerate. That's the end of our 6-part time series databases series. So see you all next time.